please take out this handout from your notes in order to follow along with this lesson. In the last lesson, we looked at finding side lengths with trig ratios. This time, we're finding angles with trig ratios. But the trig ratios themselves are the same. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And just as a reminder of how to label the triangles, hypotenuse is always directly across from the right angle. Opposite is always directly across from your chosen angle. And the adjacent is just the other side. So just like before, we need to label our triangles, find out which trig ratio to use, plug in our numbers that we know, and then solve for the one we don't. So in this first example, find the measure of angle A to the nearest degree. Well, angle A is this angle right here. I'm going to start by labeling my triangle. So here's the right angle. This is our hypotenuse. Directly across from angle A would be our opposite side. And the side left over would be our adjacent side. The opposite side is not given, so it's not helpful in finding this angle. So this angle requires the use of adjacent and hypotenuse. So which trig ratio uses adjacent and hypotenuse? This one, the cosine. So that's the one we're going to start with. So cosine theta equals adjacent over hypotenuse. Theta is our unknown angle in this case, which is A. Adjacent is 17 and hypotenuse is 22. Now we can do 17 divided by 22. It comes out to 0.7727, rounded it to the fourth decimal place. And a lot of people will stop here and say, well, that's the answer. The angle is 0.7727 degrees. Or they'll do something weird and multiply by 100 because they think it has something to do with percent and say it's 77 degrees. Well, that's not right. This is not the angle. This is equal to the cosine of the angle. So we have to do an extra step here. We know what the cosine is. Now we need to work backwards and find out what the angle is. So when you work backwards, you're doing the opposite operation. So the opposite of cosine is inverse cosine. So we would write it like this: A is equal to the inverse cosine of 0.7727. So to type this in your calculator, you have to find where the inverse cosine function is. Well, it's usually the second function of your cosine button. So most calculators, in the top left corner, you'll see shift or second function. You would press that button and then press your cosine button. Now you've got the inverse cosine. And when you do that, you should get an answer of about 39 degrees. So if you try this on your own and you're not getting an answer of 39 degrees, something's wrong. Let me know and I will help you figure out how to do this in your calculator. If everything's good, then you can move on to these three questions down here, and you can try to find angle A using the same kind of method as we did above. So pause the video and try these and then check back in. For the first one, I labeled the sides. If this is the angle I'm trying to find, that's opposite, that's adjacent. So because I'm using opposite and adjacent, then I have to choose tangent. So tan of angle A is equal to 6 over 11. Because I want to solve for the angle, I have to do the inverse tangent. Similar to the example above where I did the inverse cosine, I'm just doing the inverse tangent. So you can do your 6 divided by 11, do the inverse tangent of that. You should get an answer rounded to a whole number as 29 degrees. For the next one, we're using the adjacent side and the hypotenuse, which means I choose cosine. So the cosine of the angle is 14.1 over 19.2. But remember, since we want the angle, we have to do the inverse cosine of that. So our answer should be 43 degrees. For the last one, we're using opposite and hypotenuse. So I choose sine. The sine ratio is opposite over hypotenuse, or 23 over 26 if we're solving for angle A. And because we're solving for the angle, we have to do the inverse sine. And we end up with about 62 degrees. If you had trouble with any of these, or if you still have questions, please let me know and I'll do my best to help you. Otherwise, move on to the next question. For this question, you're asked to solve the triangle. Remember, solve means find all the missing angles and all the missing sides. You're given two sides and you're given one angle. So you need to figure out the missing side and the two missing angles. And you can use any trigonometry tool we've used so far. We know that all the angles inside the triangle have to add up to 180 degrees. We know that we can use Pythagorean theorem if there's a right triangle. And we also know how to use sine, cosine, and tangent. So pause the video, try to solve this triangle, and then come back to see how you did. I started by finding the missing side. Since this is a right triangle and I know two sides, I can use Pythagorean theorem to find the third. I labeled it as side C because it's opposite angle C, and this is the hypotenuse, so I make sure I put my unknown in the hypotenuse spot. Then I just plug in my other sides, do the math, remember to take the square root, and I end up with about 13.6 as this missing side length. Then I looked at angle A. So angle A has this as its opposite side, this as its adjacent side. So opposite and adjacent, I'm choosing tangent. So plug in my numbers. Remember to take the inverse tangent because I'm looking for the angle. It ends up being 17 degrees. And then I remembered that the three inside angles of a triangle have to add up to 180 degrees. So knowing that, I know that angle B must be 73 degrees. Now you might have solved this problem in a different way, but we should be getting similar answers. So if you have any questions about this problem or any of the previous examples, just let me know and I'll do my best to help. Otherwise, move on to the practice questions.